and good day, pre-algebra. We are going over odds today. CO43. It's been a while since we've done a live video, so happy to be back doing these. And our first order of business is to compare odds versus probability. Okay, Jeffrey, tell me about probability. What have we learned about? What were we talking about? What have we learned about?
It's like an chance.
Okay, so the likelihood of an event occurring. What does probability compare? Like if you've got the probability of something, we'll say the probability is 2/5 or 2 out of 5. What does the 2 and the 5 represent?
How many times it happened out of 5?
Okay. Kind of more defining what we talked about, Liam.
The odds that it can happen?
Well, that's what we're getting to next, right? This is probability here. We're going to relate this to odds shortly. But the 2 and the 5, what do those two numbers, or the numerator and the denominator of a probability, represent? Okay?
Say what will probably happen.
No? Flip back in your binder to, what was it, CO39 probably, where we defined what probability is. Tony? Okay. Look right below that. There should be a little something else there. Camille?
It's just a scale of the probability.
Scale of probability. Maybe it's the next page then. Kate? Okay. Right? And we kind of shorten that to be successful outcomes over possible outcomes, right? If the probability of something is 2/5, that means that there are 2 things we want to happen, 2 successful outcomes out of 5 things that could happen. Okay? What probability compares is successful outcomes divided by possible outcomes. Okay, successful outcomes divided by possible outcomes. What odds do is odds compare successful outcomes to unsuccessful outcomes. Okay, what odds do, and you'll notice this kind of ratio symbol that I have here. Odds are written as a ratio because it compares a part to a part. The part that's successful to the part that is unsuccessful. Whereas probability compares a part to a whole, right? The part that is successful compared to the whole. What could happen? The possible outcomes. Okay? So this is a ratio symbol here, and odds are written as a ratio because it compares the part that's successful to the part that's unsuccessful. So if we're using our 2/5 here, and we want to write that in terms of odds, we have 2 successful outcomes. How many unsuccessful outcomes are there? Okay? No, 5 is how many possible outcomes there are. If 2 are successful and 5 are possible, how many unsuccessful outcomes? Why? 3. So the probability 2/5 can be written as 2 to 3 odds. Because of those 5 outcomes, 2 are successful, 3 are unsuccessful. Right? And the reason why, like I said, odds are written as a ratio is because if you notice, you add those parts together, it gives you the whole. It gives you 5. Okay? So the value of odds is it identifies both the parts, but you can also identify how many outcomes there are total. Okay? Questions on the difference between probability and odds? Both of them contain the number of successful outcomes, right? They both have a 2 there. But probability then compares that to with the possible outcomes, the total, the whole, versus odds compared to the other part being the unsuccessful outcomes. Okay? So, down the line over here, it says you have a standard 52 card deck. Write the probability as a fraction n percentage and the odds of each event occurring. Answers need to be in simplest form. I do help you a little bit, and I tell you how many of each card there is. So in a 52 card deck, choosing an odd numbered card, there are 20. Okay, there are 20 odd numbered cards in a 52 card deck. So what is the probability of choosing an odd numbered card? If there are 20 of them out of 52 cards possible. Shay? 20, 50 seconds, right? 20 successful out of 52 possible. Right? That's what probability compares. Successful to possible. The part for the whole. Now it does say to write this in simplest form. So what is 20, 50 seconds written in simplest form? Haley? 5/13. So we can divide both 20 and 52 by 4. So you have 5 out of 13 chance. It says to write it as a percentage. How would you calculate the percentage 5/13? Blake? In your calculator, you take 5 divided by 13, or 20 divided by 52. Yep. And what percent do you get? You can round it. 38. Do you have a second on that? Yep. Okay. 38%. Right? So that's the probability written as both a percentage and a fraction. Focusing on that fraction being successful divided by possible. The odds of the events. Okay? This is the new one. This is where comparing successful to unsuccessful. How many successful cards are there? How many successful outcomes are there? Picking an odd. Abby? 20. Notice that our probability, that 20 right here, right? And our odds, 20, the same. Both of them contain that successful part. But now odds, compare that 20 to unsuccessful. If there are 20 successful and 52 total, how many unsuccessful are there, Liam?
32.
32. So the odds would be 20 to 32. Since it's a ratio, and we've already talked about this year, how to simplify a ratio, what would this simplify to be? Similar to a fraction. Haley? 5 to 8. Divide both by 4, right? Divide by 4, divide by 4, and we get 5 to 8. Do you see any connection with our simplified fraction and our simplified odds? Tell me what connection you see here between our simplified fraction and our simplified odds. Abby? They both have 5. What else? Liam?
If you add 5 and 8, it equals 13.
Exactly. You add 5 and 8, you get 13. Why does that work out? Because, again, a fraction compares successful to possible. Even our simplified form, 5 successful out of 13 possible. Odds compares successful to unsuccessful. 5 successful, 8 unsuccessful. Total, if you add the successful and unsuccessful together, you get the possible, which is 13. So that relationship exists both with the original fraction and original odds, as well as the simplified fraction and the simplified odds. Okay, Tony?
Are you getting 32 for that?
Because if there are 52 cards total, 20 of which are successful, then 52 minus 20 means there are 32 unsuccessful ones. Okay? So basically, these two numbers here should add to be the denominator of your probability fraction. Okay? The next one, choosing a face card. There are 12 face cards in the deck. 4 jacks, 4 queens, 4 kings, What's the probability of choosing a face card? What's the probability of choosing a face card? Tony?
12 out of 52.
12 out of 52. 12 possible divided by 52 total. 12 possible divided by 52 total. Let's skip the simplifying the percentage for now, just to focus on that odds piece. Okay? If the probability is 12 out of 52, what are the odds? What are the odds? Why?
12 to 40.
12 to 40.
How'd you get 40?
Good question. How'd you get 40? Why? You're right. It is. But how'd you get there?
12 minus 52.
Right. Remember what odds compare? Odds compare the two parts. How many successful, how many unsuccessful. If you have a total of 52, which is what our fraction tells us, right? This 52 is the total number of cards possible. If 12 are successful, take those 12 away from our 52 and we're left with 40 unsuccessful. Okay? And again, it's no coincidence that these two numbers here, 12 and 40, add to be 52. Odds tell us a little bit different information than the probability fraction does. Okay? If you saw odds of 12 to 40, is that likely to happen to work in your favor or unlikely to work in your favor? Unlikely, right? There are only 12 successful versus 40 unsuccessful. Okay, just like you look at 12 out of 52 and think, ooh, that's not very likely to happen. Right? You can get the same determination from odds. Okay. Choosing a black card. There are 26 black cards in the deck. What's the probability of choosing a black probability? What's the probability of choosing a black card? Jack?
26 over 50.
26 out of 52. There are 26 successful outcomes out of 52 possible ones. Right? If you were to simplify this, 26 out of 52 equals 1/2, right? You have 50% chance of picking a black card, 50% chance of picking a red card. It's an equal number of each. How about the odds? I know my first number is going to be 26 because that always matches that numerator of my probability fraction. Both of those show the possible outcomes. Or sorry, both of those show the successful ones. How many unsuccessful ones? Okay, also 26. Right? You know that if there are just as many successful as unsuccessful, you have an equally likely chance of picking either. That's 50%. That's 1/2. Okay? What's 26 to 26? Written in simplest form.
1.
1 to 1. Right? 1 to 1. Okay? You have a 1-to-1 chance. Equally either way. One successful for every one unsuccessful. Are we starting to get this? Is there questions? Okay, where are you getting lost?
After you put fraction.
Okay, so it's the odds piece of it. It might be helpful just to remember, and we wrote it up above, but I'll reiterate here. So what does probability tell us? Okay, probability tells us successful over possible. Okay? What do odds tell us? Odds compare successful to unsuccessful. So first thing, note that this first part of the probability and this first part of odds are always the same. both of them show the successful outcome. So let's start there. Choosing a diamond, there are 13 diamonds. So that would be our successful outcomes, right? If you want to pick a diamond and there are 13, the probability there are 13 successful outcomes are odds there are 13 successful outcomes. That's the same in each of them. But the difference is that now a probability, the denominator is the possible. How many possible outcomes are there? There are 13 successful. That's how many diamonds there are. We're dealing with a 52 card. Yeah, 52. Okay? Versus odds, compare that 13 with the number of unsuccessful. So if there are 52 possible outcomes, 13 of which are successful, how many are unsuccessful? Jack? 39. 52 minus 13 is 39. So that's where these are now different, right? Notice that 13 plus 39, add to be the whole, add to be 52, okay? But it's really important just to remember what each thing represents. What does probability tell us? What do odds tell us? Okay, does that help? Okay. Anything else? Jay?
I just tested it and I only got one.
So that would be the experimental probability, right? Versus the theoretical. Yeah. Whenever you calculate something, this is just in theory. This is what should happen. Will this actually happen? Well, that's why we try it, right? This is like the hypothesis of a scientific experiment. This is what we expect to happen. This is what should happen. But what actually happens? That's why you do it. Okay. I would like you to do for homework just the rest of this page. So the bottom three here, what does 3 to 4 odds mean? If I tell you that there's 3 to 4 odds of something happening, what does that mean to you? What could you tell? How would you put that into another? Yeah, John?
The ratio of 3 to 4.
Okay. Ratio of 3 to 4. Tell me more, Haley. Okay, 3 good outcomes, 4 bad outcomes. What else?
There could be 3 successful and 7 possible.
Sure. You can tell me there's 3 good, there's 4 bad. You can tell me the probability. You know, if the odds are 3 to 4, the probability is 3 out of 7, right? Because you add those two parts together to get the whole. Kind of anything is, what does it mean to you? Is it likely to happen? Is it unlikely to happen? Okay. 3 to 7 would fall under the unlikely to happen because it's less than 50%. There are fewer successful outcomes than unsuccessful outcomes. Okay.
Or you get 7.
By adding these two parts together. Okay. Your homework is the rest of the page. I need to see the probabilities, see the odds written out. I do want the percentage written out as well. Just get more practice with that. We didn't do it on the flash 2 examples that we did together, so you can go back and fix those, but we'll go over this tomorrow. Questions, comments, concerns, complaints, comments, congratulations, or criticisms, or...
Congratulations!
Oh, did I not say that one? No. Oh, congratulations, or clarifications.
Congratulations!
Thank you, John. No, none? All right. Homework for tomorrow. That's my math.
Don't forget to